Okay, we're back, and we're talking about uh, exponential decay, and this comes from a physics project where they're figuring out half-life, but we're not going to worry about half-life. But I will take the data that they used to figure out if something is going to decay. So this is the data that they got on the bouncing ball. So they have all the times, they have the height of the bouncing ball, and so on. So what I'm going to do is I'm going to put this data into GeoGebra and graph a exponential decay curve. So we'll jump over to that. Okay, so we're back in GeoGebra, and what I'm going to do is open up my spreadsheet view again, and I'm going to go ahead and put in all that data that I just showed you. But you know what? I'm not going to put in the times. I'm just going to put in the number on the bounce. So it's just going to be like bounce number 1, bounce number 2, and so on. So I don't have to mess around with it. I'm going to increase this by 1 each time. So 1 plus 1. And let's see, I think there's 19 bounces, so I'll go down to there. Alright, so I'll go ahead and put that in. Looks like there's only 18, so I'm going to adjust my rounding. Let's see, options, rounding. Let's go 3 decimal places. There we go. And this was 0.010, so that's okay. Now I'm going to plot these points, so drag over, oops, and create a list of points. You can right click and do that, or I think you can hit this button. List 1, create. Alright, so it created these points, but I don't see them on the graph. Because I need to zoom. Oh, I don't want the list to look like that. Delete. I want to create a list of points, not just a list. Create list of points. There we go. So those points are shown there, and let's go ahead and change our graphic view to layout. Let's change the view so that my y-axis is a little bit smaller. So y max, the biggest my number gets is 0.114, so let's make this the maximum 0.5. And the y minimum also 0.5, or negative 0.5. So it makes the graph look a little bit better, maybe even smaller, 0.25. And max 0.35. Okay, looking better. Alright, so what I want to do is get a curve fit for this. I don't like the letters again, I'm going to change that. Right click, object properties, change the label to value. So you can see that each of these points is represented on the curve. Now I'm going to go to input and create a new function. So f of x equals, so this is going to be fit growth. It's the same exact one that we use for exponential growth, but it's just the opposite of growth. It's decay, but it's the same function in GeoGebra, and it's list 1. Okay, so it looks like here my function is 0.128 times 0.876 to the x, right? This is less than 1, which is what I expected in an exponential decay type problem. So you're going to do similar things with different data sets, and you can see that this isn't completely on the line, but it's pretty close to a good estimate for what these values match up to in an exponential decay type problem.